Hi all, this is another linear word problem, and this one's a little bit different in the sort of information that we're given. It's about birds. We're told that the European sedge warbler has an intricate song consisting of a long stream of trills, whistles, and buzzes. Males with the most intricate songs are the first to acquire mates in spring. A male who sings 41 different songs is able to pair on the 20th day, and a male who sings 29 different songs pairs on the 35th day of spring. And we are asked to find an equation that gives the time it takes to pair as a function of the number of songs known. So I'm just going to, for my own reference, put what's supposed to be X and what's supposed to be Y. So time it takes to pair as a function of the number of songs known, which means the time depends on the songs. And those are not thorough variable definitions, but they work for my little scratch work to the side just to help me remember. Okay, so if you'll recall, to find the equation for a line, we either need 2 points or a point and a slope. So our first job is going to be going through the information we're given and deciding if we have points or slopes or both. So as I read through here, the first piece of information that I run into that looks like it needs to go into my equation is that a male who sings 41 different songs is able to pair on the 20th day of spring. And then the next bit of information is that a male who sings 29 different songs pairs on the 35th day of spring. And this looks exactly like point information. We have two paired pieces of information. So we know that the 41 should go with the 20 and the 29 should go with the 35. What you'll need to be careful about is which is an X value and which is a Y value, which is exactly why I draw little axes like this off to the side for myself. So songs are our X's, which means the number of songs should be the first coordinate. So I'm going to say 41 songs gets paired with the 20th day of spring, and 29 songs gets paired with the 35th day of spring. All right, let's also go ahead and do that careful defining of variables. I'm going to do it just above here because I think I crowded myself a little bit. Let's use S to represent the number of songs and T to represent the time it takes to find a mate. Now that we've been clear about what our variables represent, we can go ahead and start working on the equation. The first thing we'll need to do, given 2 points, is to find the slope. To do that, we'll just use change in Y over change in X, which gives me negative 15/12 that I can reduce to negative 5/4 or negative 1.25. Remember that in the context of word problems, it is okay to switch to a decimal. If this was not a word problem, I'd like you to use the fraction, the negative 5/4. But if we're building an equation, what we'd call our model of this situation, we don't expect it to be exactly perfect anyways. A small amount of rounding error isn't going to give us too much trouble. And we actually didn't even build up any rounding so far here because this is an exact decimal version of our fraction. So the next thing we need to do is jump to an equation, and we can use point-slope form or slope-intercept form. I've been using a lot of slope-intercept form, and I do tend to favor it, but I find that when I get to calc, I'll sort of flip-flop and use a little more point-slope form. So let's go ahead and use that now, and you can pick and choose which one you prefer to use. Point-slope form, we need our Y value, which is time is our Y variable, minus a specific time value. So we have to pick a point, and it doesn't really matter which one. I'll use this first one, and we'll use the T value from that point, so minus 20. And then we need our slope, S for number of songs, minus that value from our point, which is 41. So this is an equation for this line. I would like you to write these always in slope-intercept form for your final answer. So let's go ahead and do that. We have 2 steps we need to do. We need to distribute through the parentheses, and we need to add the 20 to both sides. So that will look like negative 1.25s plus 1.25 times 41, which ends up being 51.25. And then don't forget about that plus 20 on the end. So my final answer, and I'm going to go ahead and use my function notation as well. So this is T, time to pair as a function of S, equals negative 1.25s plus 71.25. And that is our final equation, or what we would call our model, because it's modeling the relationship between time to pair and number of songs. The next part of this question is asking us to use the model to determine how many songs a male must know to pair on the first day of spring. So the first day of spring, that's T equals 1. I guess T equals 0 would be already paired on the first day of spring. So let's set this equal to 1. Negative 1.25s plus 71.25. To solve this, we'll want to subtract 71.25 from both sides, which will give us negative 70.25, and then we'll divide everything by negative 1.25, and our final answer should be 56.2. This is telling me that we need 56.2 songs. So I'm going to round to 56. I could see an argument for rounding to 57 because 56 doesn't quite cut it. I'm not feeling that picky either way at this moment. So we will say he needs to know 56 songs, roughly, to be able to pair on day 1. The other thing I want to point out really quickly here, just as a little bit of extra practice, is the slope interpretation, that negative 1.25 over 1. This is change in time over change in songs. So I would say for every additional song that a bird knows, it will take 1.25 fewer days to find a mate. All right, I think that's all I need to add to this one. Thank you for watching.